friends, and welcome to day 3 of adding. So today we are doing pages 59 to 61 together, and then you are expected to do page 62 on your own and then show me whether it's live on Google Meet or on Seesaw, okay? So for this one, we're going to do some adding and some estimation. So estimation, for that, we need to use our good friend rounding. So there's a reason why we focused on rounding last week. See it all come full circle, friends? That's why we do it. So first things first, we need to find the sum of 57,541 and 23,098, and we need to use the standard algorithm. So that's first. So we're going to split our paper into 2 again. So first things first, we need to add using the standard algorithm. So we have 57,541, and remember, we need to line up by place value. So we're going to have 23,098. Now notice how nicely my place value lines up. It's going to be way easier this way to go and add. So we have all the way to the right, we're going to start. We have 8 plus 1, which is 9. We have 9 plus 4, which is 13. So we're going to have a 3 and carry the 1 over to our friend in the hundreds. Then we're going to have 5 plus 1, which gives us 6. 7 plus 3, which gives us 10. So we have a 0 here, carry the 1. Then we have 5 plus 2, which is 7, plus 1 more is 8. So that's our answer exact. This is the sum of 57,541 and 23,098. But we need to do an estimation. And like I said, estimation has to do with rounding to check our answer. So we're going to round these two numbers to the nearest 1,000, okay? So for example, we have 57,541. And we're going to round to the nearest 1,000. So I'm going to circle my thousands place, underline my rounding buddy. This rounding buddy is 5 or more, so this is going to get bumped up to an 8. So we have 58,000, okay? And then for 23,098, we're going to do the same exact thing. We're going to round to the nearest 1,000. So I circle my thousands and underline my rounding buddy. This rounding buddy is 4 or less, so we're going to stay and rest. So we have 23,000. And then from there, we're just going to add. It's a little off by lining it up. We can make do. We have all these zeros, so they're going to stay zeros. And then we have an 8 and a 3, which gives us 11. And then we have a 5, a 2, which is 7, and then an 8. So that gives us 81. So with us estimating and rounding, we got 81. Our exact answer was 80,639. Now, based on what we know about rounding and number sense from the last couple weeks, we can figure out, friends, that 81,000 is actually pretty close to 80,639. And remember, when we rounded, we had all of this extra to deal with. So it makes sense that we're a little higher, but it's close enough to figure out that, hey, we're on the right track. This must be correct, okay? So I know that was really fast. If you have any questions, please join the Google Meet and ask, because I'm more than happy to help you, and we will figure it out together, okay? We're going to have lots of practice with this word estimation, I promise, okay? So moving on to page 60, again, it's just a little reading for you. So it's just 2 different strategies that you could use. So using the algorithm to add, which is what we did on the first page, and then this is how you could estimate. So this is basically just the word form of what we did on the first page, okay? So make sure you read this, because this is very important in understanding how these numbers work, okay? But moving on, make sure you pause here, because you need to read this, and then you can move on to page 61, okay? So 61 is just making some more connections, because we love making connections oh so much. So for number 1 is asking us to finish this problem. So this is the problem it wants us to finish. So it already did some adding for us. It did 8 plus 1 is 9. 9 plus 4 is 13. So now we're going to finish it. We have 5 plus 1 gives us 6. 7 plus 3 gives us what? 11, just like earlier. And then 5 and 2 and 1 gives us 8. So that's us finishing the problem. But number 2 is asking, why did we have to regroup again? Why did we have to put a 1 here? And that's easy, right? We know this from the last couple days. When we added the thousands, we had a 7,000 and a 3,000. So technically that gave us 11,000. But we know we needed to make a transfer to the 10,000s because we can't have 11,000s in one place value. We need to split it up, and we need to cash in some of those thousands for a 10,000. So the answer is there are 11,000s so we needed to regroup $10,000s as 1 10,000. So it sounds tricky, but that's just saying that we cashed in 10,000 to make it 10,000. So now it'd be 10,000 plus 50,000 plus 20,000 gives us 80,000, okay? So if we look at the second model, so we look here, is it fair to say that the estimate of 81,000 is close to the sum you wrote? Well, yeah, because our sum was 81,639. So 81,000 is definitely close, and that means it is definitely reasonable. It makes sense because we are still pretty close. We're 600 away, but because we're estimating, that's pretty normal to be that far away. So we know we're reasonable, and we know we're on the right track. So in the second modelet, I'm looking at number 4 now, each number is rounded to the nearest thousand. Could you estimate in different ways? For example, what are the benefits and drawbacks of rounding to the nearest 10 instead of the nearest thousand? So we know from rounding last week that we can round to different place value and still get generally the same answer. So the smaller we go, we just know from last week we get a more exact number. It's more close to the sum, right? So you can round to any place value to estimate. But the smaller the place value, the closer to the exact sum your estimation will be. Okay? So any way rounding is okay. Any place value you want to round to, as long as you do it accurately. But just know that the smaller you round to, the more exact it is. So it might be easier to round to the larger place value just to get the number more generalized, okay? So I just want you to think about number 5. And I want you to tell me, I like this new theme we're starting. I want you to tell me in the Google Meet what you like or do not like about using the standard algorithm if comparing it to other strategies. So why do you like the standard algorithm, or why do you not? Why do you like drawing better? Why do you not? Just tell me how you're feeling about this, okay? I want to check in. So you need to tell me in the Google Meet right now how you're feeling about the standard algorithm, okay? And then once you do that, you can start page 62 on your own, and then make sure you just check in with me either on Seesaw or Google Meet to get credit for completing page 62. If you have any questions, I'm here, friends, so make sure you ask. We have one more day of workbook pages, so we are almost there. We're in the home stretch. So please ask questions while you still can. I'm here to help. Happy math!